Risk and return, part 2. After going through part 1, we were able to connect the relationship between profits and returns on an investment. We were able to define what is risk and how uncertainty relates to risk. We saw the historical returns of stocks, bonds, and bills, and were able to calculate the risk and returns for these investments. We also calculated the standard deviation and variances using these historical data. We calculated the expected return and the standard deviation, and then we interpreted the trade-off between risk and return. After going through this presentation, students would be able to calculate the returns and variance through conditional returns and probabilities, and using multiple stocks to create a portfolio. They'd be able to interpret the benefits of diversification when they create portfolio and how diversification helps with risk minimization. They'd be able to analyze the difference between systematic risk and unsystematic or stock-specific risk. Later on, they would be able to create the beta of a portfolio to create a certain specific target risk that they want to incur. And then we'll talk about the capital asset pricing model and how to create a target using a capital asset pricing model in the security market line. Now let's talk a little bit about probabilities and how expectations or average values come in with the help of probabilities. So let's assume that an event is associated with certain outcome. For example, event 1 will have an outcome 1 with certain probability, outcome 2 with certain other probability, and a bad outcome 3 with certain probability. Now notice that there's a 100% chance that some outcome is going to happen. We just know that the outcome set is fixed. So the expected payoff then would be the probability of event outcome 1 times the payoff from outcome 1, probability of outcome 2 times the payoff from outcome 2, and the probability of outcome 3 times the payoff from outcome 3. Excuse me. The expected payoff therefore would be just represented here as sum of I equals 1 to 3 of the probability from that event I times the payoff available from that event I. So it's just a sum of PI, the probability, times OI, I going from 1 to 3, because remember there were 3 possible outcomes. Now this can be extended to 4, 5, 6, however many outcomes that we can have. So in general, therefore, we can say the expected value of payoff is sum of I equals 1 through K of PI OI. Now let's take up an example, very specific. In this case, we'll create 4 outcomes for 4 different types of situations in an economy, not 3 times, but 4 times. The normal times with a probability of 45%, boom times with a probability of 25%, stagnant times with a probability of 20%, and recession with a probability of 10%. Now these can be represented in a table like this. So in this table, we have just defined that time or the business cycle: boom, normal, stagnant, and recession, and its associated probability: 25%, 45%, 20%, and 10%. Now let's assume our stock called S1, just a random name, S1. It could be a Google or a Microsoft or a Delta Airlines or a Boeing, etc. So produces a return during boom times on an average of 20%, in normal times of about 5%, in stagnant times about 1%, and in recession of about 4%. So we will use Excel. So I've already put these numbers here. So we will use Excel to find the product. So equals 20% times, remember the formula, right? It is the payoff times the probability of the outcome. Payoff times outcome. So control D, control D, control D. And the sum total of all of these is the expected value of the stock return, which is 7.05%. But wait, there's a formula in Excel which can do the same thing for us. It's called the sum product. So it just says sum product B2. So here we'll say $B $2 colon $B $5 comma. So we select one array and then we select the other array and just take the product. Same thing. So all we need to do is alt est enter. So format, paste special, and paste. So you can see that we don't have to go through all this complicated process. We can just use the sum product function to get the 7.05% expected return from the stock, which is what is available in the table. So we multiply the probability with the outcome to get the product, add up all of these products and do the same thing for all particular scenarios of 4 possible times that we have, and then add them up to get the 7.05%. Moving on. So how do we get standard deviation and variance from the average or the expected value? So the first step is to calculate the deviation. The deviation is actual minus expected value, and then square the deviation, multiply it again with the probability and then add it up to get the variance. So variance is sum of probability I times deviation of I squared, and the standard deviation is square root of variance. So there should be a summation sign right there. Okay, so let's demonstrate that. So here is the example. So again, remember we calculated the probability and returns. Now we have to calculate deviation squared. So let's go back to Excel. So I'm going to remove this here. Let's first calculate in a simple way deviation, and then let's calculate the deviation squared. So the deviation is just nothing but the actual return minus the average or the expected return, $6. That is a deviation. So it's 20% minus 7.05%, which is 12.95%. And then the next one will be 5% minus 7.05%, which will be minus 2.05%. Then minus 6.05%. And then this will be plus 11.05%. Minus 11.05%, I beg your pardon. Squaring the deviation equals this to the power 2, about 168 point something, 167.7%, and then 4.25, something like that, and then 36.3003, yep, and then 121, something like that. And then so now we use the same sum product function that we used here. See that sum product function? And that was why we fixed the b's, because the b's are probabilities. So what we do is let's take the sum product of deviation squared with the actual probabilities to get the variance. So this is called variance. Variance, and let's put an arrow here. This is the variance. Insert close. This is the variance, or OCA. And then standard deviation, again let's get the same arrow out, is the square root SQRT function in Excel, or you can just say equals this to the power half or 0.5, same thing. Square root function is just a fancy way. So the standard deviation of this stock is 7.96%, and the expected return, so let's just call it expected returns, RTRNS, is 7.05%. And that's exactly what we got here. See, 7.05, 7.96, etc. So what did we do? We took the difference of the returns from the expected value or the average to get the deviation, squared that deviation, and then did the same thing for all the 4 different scenarios times, and then took the sum product of probability with the squared deviation to get the variance. Took the square root of variance to get the standard deviation. So standard deviation here is 7.96%. Okay, what is the risk return trade-off? Once again, if two investment, we'll talk about the risk return trade-off just a minute. We know that high the risk, high the return, and so on. But if two investments yield the same return, then we choose that investment which gives us lower risk. If two investments are having the same risk, we choose the investment which has higher return. It's pretty obvious, right? So this is a rule for investing. Now we're going to mix up 2 stocks, stock 1 and stock 2. So we already have that in Excel, and we also have the deviation. So let's bring in stock 2 in the equation here. So I'm going to bring it in here, take the deviation squared directly this time. So okay, so we don't need to calculate it again and again. So equals, wait, first we have to calculate the sum product. All we do is, I'll insert a column here just to keep a differentiation between S1 and S2. All right. So what did we do? We took the sum product of the probabilities. Let's just say these are the different times. These are the probabilities. And took the sum product of the probabilities with their expectation. Now let's just quickly look at what the second stock is doing. So in boom times, stock 1 is doing fantastic, but stock 2 is not doing good. People are not buying stock 2. And in normal time and stagnant times, however, stock 2 is seeming to do a slightly good job. In recession though, everybody is buying stock 2. That's amazing. So stock 2 could be something like maybe a gold or a treasury bill or a bond, etc. Nobody likes to take care of it when the markets are doing well. And so therefore the expected return of stock 2 is not as good as expected return of stock 1. Expected return of stock 1, let's put it in green, and expected return of stock 2, let's put it in blue. So people don't prefer the blue portfolio in their portfolio as compared to green. But wait a minute, not so fast. We can do something really cool here. So let's just take the deviation squared here, equals parenthesis this minus, so actual minus exposed, so $G $6 to the power 2. That's our deviation squared, right? And then just do control D, control D, control D, and then take the formula for variance, sum product. So sum product is done, okay? And then take the formula for standard deviation, copy and paste to the power half. Now, so what interesting thing we notice is lower expected returns, but also lower standard deviation, which means stock 2 is less risky than stock 1. But the best part is if we plot this stock 1 and stock 2 performance over different times, stock 1, stock 2 over different times, it's not going to give us a very good this thing. Right. All charts. Let's try the XY scatter, other line. Yes, this is very interesting, right? So in boom times, stock 2 does not do well, but in normal to stagnant times, both of them do similarly. And so these are perfectly inversely correlated with each other. And that's actually, we can show that's actually great for our portfolio. When the markets are doing bad in stock 1, at least we have something to save us in terms of stock 2. And so that's the objective of creating a portfolio. So let's see what have we done so far. So far, we've created the expected value of stock 1. Then we created the expected value of stock 2. Then we took the squared deviation of stock 1. We got the squared deviation of stock 2. We got the variance of stock 1. We got the variance and standard deviation of stock 1. We got the variance of stock 2 and the standard deviation of stock 2. That's what we've done so far. Now let's mix it up. Let's say our portfolio contains 60% stock 1 because it's doing well and 40% stock 2. So we'll create a portfolio. So this is called portfolio. So here we'll create portfolio which contains 60% stock 1 and 40% stock 2. So in boom time, stock 1 gives us 20% returns times 60% value in stock 1. And then stock 2 gives us very bad, minus 4% times 40%. So our portfolio gives us only 10% in good times. It gives us 3% in normal times. It gives us 3%. Wow, nice. In stagnant times. So look at that. Whether the times are normal or stagnant, our portfolio is seeming to do pretty all right. And then it gives us, wow, 3.6% in a recession. That's amazing. It was going to give us minus 4% with just stock 1. On the other hand, it was going to give us minus 4% in boom times with stock 2. Now look at this. What we've done, Shift Control 5 and Alt H0 gives us 1 decimal place. Now the portfolio seems to be doing just fine across all the different times. And that's amazing, right? So expected returns of the portfolio, 5.17. Let's call this as, don't know, maybe yellow, somewhat of a yellow color. That's our return. So our return is between 7% and 2%. That's 5.17%. So that's interesting. The last step would be to take the deviation. So I'm just copying and pasting it. Look, so instead of G6, we have to do J6. J6, 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 and J6. So look, J6, take the deviation and square it. J6, take the deviation, square it. Take the deviation, square it. and then some product with the probabilities of the deviation squared. Gives us the variance, and the standard deviation is the square root of variance. Now, what is important is the standard deviation. Standard deviation was really high with stock 1, that there, 7.96. Standard deviation was still high, relatively speaking, with stock 2. But look at that. Our portfolio has very small standard deviation as compared to both stock 1 and stock 2, meaning that we will get 5.17% sure shot, more sure shot than either stock 2 or stock 1. And that's the beauty of creating a portfolio. A portfolio will keep giving us steady returns no matter what the times are. And that's what we learn from creating a portfolio in the real world. So with a 60% stock 1 and 40% stock 2, we multiply the weightages, the mix, with the returns to get the return of the portfolio. And then we calculate the similar returns and average them out to get the expected value of the portfolio. And then we take the deviation squared and then take the sum product to get the variance. Finally, we take the square root to get the standard deviation. Then we notice that our portfolio expected value is in between stock 1's expected value and stock 2's expected value of 7 and 2% approximately respectively. And the shock that we really get is the standard deviation of the portfolio is much lower than the standard deviation of either of those two stocks. So that's the beauty of creating a portfolio. We can play around with these mixes as we like, 60-40, 40-60, etc. It is per the desire of the investor. Okay, so what we learned is the expected value was between 7% and 7.05 and 2.35%, and the standard deviation actually shockingly went down. So this means that we've reduced the risk, but the returns are not substantially reduced, and the key is the returns should be as uncorrelated as possible. So the graph that we saw in Excel, this graph here, that they are uncorrelated with each other across good times and bad times. That's the key. Okay, as we add more and more stocks to the portfolio, our risk that we have with respect to one stock decreases. So imagine holding a stock of a company and the company goes bankrupt. The stock price goes to 0. But if only that stock was very small percent of our portfolio, then our portfolio is not really greatly affected by the bankruptcy of that stock or the company of that stock. So risk decreases as we add more and more company stocks in our portfolio. However, it levels out. It doesn't go to 0. It levels out to a non-zero value, and the reason for that is the entire market has certain risk attached to it, and that is called the market risk or systematic risk. So some of the reasons for why there is market risk is if the unemployment rate shoots up, or if the whole economy is doing very bad, the entire stock market will go down, and that is called systematic risk. It is a overall country-specific risk which cannot be diversified off, or can only be diversified off by choosing securities which are not really greatly affected by that systematic risk. So the firm-specific risk is called unsystematic risk, and it can be diversified, particularly by mixing stocks that are unrelated, correlated with each other. For example, a technology stock like Microsoft mixed with an aviation stock which is pro-cyclical, such as Delta Airlines. They're uncorrelated, they're not really connected with each other. And so that's how we can create a diversified portfolio, by choosing different sector stocks, good stocks from different sectors. And so if we plot the total risk as measured by the standard deviation with respect to number of stocks in the portfolio, on the x-axis is the number of stocks. As we increase the number of stocks, the standard deviation of our portfolio keeps going down, but does not go to 0. It goes to a certain value asymptotically, which is called the systematic risk or the market risk. To conclude, probability is used to measure the likelihood of all kinds of events, and it helps us compute variance and standard deviation. Variance is the probability weighted sum of squared deviations from actual from average. Standard deviation, square root of variance. Higher expected return, meaning higher risk, generally speaking, as expected. So stocks are more risky, so they have higher expected return, but also higher standard deviation. Stocks compared with government bonds and bills. Bills are least risky, so they're standard deviation is the lowest. So variance and standard deviation are used to measure risk. Higher the variance, higher the standard deviation. For the same risk, we prefer higher return. For the same return, we prefer lower risk. Diversification helps us bring down individual stock-specific risk. And when we add more and more stocks to our portfolio, as we saw on the graph, it creates a diverse portfolio, and we can cut down the unsystematic risk. We cannot diversify all of the market risk, and that risk is called systematic risk. That's Risk and Return, Part 2. Thank you for listening.